So, section 8.5, day 1, page 582. And we're going to add and subtract rational expressions now. Now, remember we're dealing with rational expressions, which means we're dealing with fractions. So let's stop and think about how we go about adding fractions together, such as 2/3 plus 1/5. In order to add or subtract fractions, what do we have to have? Common denominator. This is why adding and subtracting is more complicated than multiplying and dividing. Did we need common denominators the last 2 days? No. Multiplying and dividing, we don't need them. Okay? Multiplying and dividing are like glue. Multiplication and division glue anything together, whether they match or not. Okay, they glue them together into one piece. We don't need common denominators because the denominators change anyway. Right? When we do 2/3 times 1/5, you get 2/15. This denominator didn't match either of the originals. That's why they don't need to match, because it changes anyway. But with adding and subtracting, when you add and subtract them, the denominator doesn't change. And that's why they must match to begin with. So what is our common denominator going to be here? 15. So we make this one over 15. We make this one over 15. Now, what did we multiply 3 by to change it into 15? 5. So if we multiplied the bottom by 5 to get a common denominator, we have to also multiply the top by 5, which becomes 10. Now, do I want to cancel the 10 and the 15? No. Doesn't that get us right back to where we started with 2/3? So you don't want to start canceling at this point, guys. That's not the purpose. We need to put this stuff together, so we need that common denominator. What do I multiply 5 by to change it into 15? 3. So I have to multiply the top by 3, which gives us 3. Now I can put them together into one big fraction with a 10 plus 3 on the top, which gives us 13 out of 15. Does that simplify it all? No. Now, what happens if we have something a little more complex, like 2 over, let's say, 21 plus 3 over 30. Let's do a minus this time. So now we need to get a common denominator. What's the lowest common denominator for 21 and 30? Not 30. Not 3. Well, here's the thing, guys. 630 will definitely work. You can always multiply the two together. The problem is that is not the lowest common denominator. That is just a common denominator. Okay? Just put it in recycling. Now, you could always... No, not 210. Oh, 210 is the lowest common one. Now, listen carefully, guys. So, let me show you how to find the lowest common denominator, because while you can use any common denominator to get a common denominator and add these or subtract them, we do not want to use anything but the lowest common denominator when we're dealing with rational expressions. The reason is that we have variables involved. And we have to factor these things. And if we don't use the lowest common denominator, that means we have extra x's and things involved in our problem. And the issue that causes to arise is that if you put extra copies of variables into your problem, you may have trouble factoring it to try and cancel later on. That causes major issues for us. So we want to avoid that. So we need the lowest common denominator. So what I'm going to do is I'm going to show you guys how to get the lowest common denominator every time without any trouble. Okay? So we're going to talk about 21 and 30. And what we're going to find is we're going to find the LCM, which is the least common multiple. The least common multiple, when we put it on the bottom of a fraction, becomes the lowest common denominator. Okay? So we need to find the smallest number that 21 and 30 both go into. We're not looking for the smallest number that go into 21 and 30. We need to know what do 21 and 30 go into so that we can figure out what we have to multiply them by to get them to match. Okay? What does 21 break down into? 7 and 3. Does it break down any further? No. So that's it. What does 30 break down into? 5 and 6, or 3 and 10. Doesn't matter how you start it, you're going to end up with the same numbers at the end. Okay? That's the idea. Okay, it turns out that the prime factorization of whole numbers is unique, meaning there's only one way to do it. No matter how you start, you will get the same answer at the end. The only difference will be you might get them in a different order. Right? Somebody that does 3 and 10 may write down a 3 here and then a 5 and then a 2, but it's the same 3 numbers. Okay, it's unique. So this is what 21 wants. This is what 30 wants. I'm going to give you guys an analogy that I came up with years ago so that I could teach this stuff with just regular numbers to my Math A classes, essentially my pre-algebra classes. Okay? It's corny, but it works. Okay, it will help you understand what you're looking for to create the lowest common denominator when it's not quite so obvious. So that is this, guys. We need to figure out which of these factors need to go into our LCM, our least common multiple. And the way you do that is this. Imagine that your mom is going shopping at the market. And before she leaves, you and your brother or your sister, whoever it is, tell her what you want her to bring home to snack on or whatever. So this is you, the 21, the 30, let's say, is your brother or your sister. Okay? You tell her, okay, I want a 7 and a 3. So you want a box of cereal and a bag of potato chips, whatever it is. Your brother or sister wants, let's see, a different box, different kind of cereal and a bag of potato chips and milk. That's pretty boring, but okay, milk to go with your cereal. All right. Now, here's the thing, guys. Mom wants you guys to be happy because Mom is sick and tired of hearing you whine and complain if she doesn't bring home what you want. But at the same time, groceries are expensive. She doesn't want to bring home anything more than she needs to bring home to make you both happy. She just wants to shut you guys up, right? So here's a shopping bag. She needs to figure out what has to go into the shopping bag to make you both happy. So to make you happy, what does she need to put in the shopping bag? A 7 and a 3. So now the 7's there, the 3's there, you're happy. In order to make your brother or sister happy, what does she have to bring home? A 5, a 3, and a 2. Now, here's the thing. You and your brother or your sister can share things. Just because you want a bag of chips and your brother or sister wants a bag of chips doesn't mean she needs to buy 2 bags of chips. You can share. She knows that you both are just going to take a look in the bag when she comes home and make sure that the things you wanted are in the bag. Okay, you're not going to take them out of the bag. So when you look in there and see your 3, your bag of potato chips, and then your brother or sister looks in there and sees the 3, the bag of potato chips, you're both going to be happy. You both got your chips, right? Even though it's the same bag. Okay? So, to make your brother or sister happy, Mom needs to get a 5. Is there already a 5 in the bag? Nope, so we need to put a 5 in the bag. Your brother or sister wants a 3. Is there already a 3 in the bag? Yeah, so we don't need to put another 3 in the bag. Now, if your brother or sister wanted 2 3s, then she would have to put 2 3s into the bag to make your brother or sister happy, even though you were going to share one of them. Does that make sense? Okay. What about the 2? Do we need to throw that in the bag, or is it already there? Need to throw it into the bag. So, this now gives you your 7 and your 3. You're happy. Your brother or sister gets their 5, their 3, and their 2. They're happy. If I multiply these all together, 7 times 3 is 21, times 5 is 105, times 2 is 210. That means that our LCM is equal to 210. Everybody see how that works? Don't forget, I warned you before we started this that it was corny, but it works. Okay, let's go back now. We now know that this is going to become something over 210 minus something over 210. Now, what do we need to multiply this by to change it into this? 10, the 2 and the 5 that your brother or sister wanted, right? That's where that 10 comes from. So if I multiply the bottom by 10, I have to multiply the top by 10. That's 20. What do I multiply 30 by to change it into 210? The 7 that you wanted, that your brother or sister didn't want. 21. Now this becomes one big fraction, which gives us what as an answer? That's how it works. So that's the way to find the least common multiple. Now obviously we're not going to be working with just numbers. But does everybody understand that process? So when I refer to, what does mom need to put in the bag, you guys all understand what I'm talking about and that I'm not just losing my mind. I am losing my mind, but I'm not just losing my mind. You guys got that, right? Any questions about the whole bag idea? You break them down into their factors, and then you put factors into the bag enough to make both or three or however many kids there are, everybody happy. But they can share things. If each one wants 1 or 2 or whatever, they can share whatever they have in common.
You only put like one.
You put the minimum amount of everything that you can get away with.
So like if they're both sharing 3, then you don't have to do it.
You don't have to do it twice. But if one of them wants 2 3s, you got to put 2 3s in, or that one won't be happy. Right? But yes, you don't need 2 3s if each one only wants 1. They can share the 1. Then there'd be 2 3s in there. You'd put 2 3s in to make the first one happy, and those 2 would also make the second one happy. You don't need 4 3s because they can share both of the 2 they want. Okay, folks, now, here's the point of this thing. Let's now talk about a more complicated example of this. So let's talk about 4x squared minus 16. And let's talk about 6x squared minus 24x plus 24. We need to figure out what is the LCM. So we want to find the LCM. What this is doing is this is just getting us some practice in finding least common denominators, right? Without doing the whole fraction part of it. We're just going to find what's going to end up being our lowest common denominator. So you will have some problems that ask you to just do this. So the first thing we have to do is we have to factor this. This, of course, factors into 4x squared and 16, right? Yeah, if I multiply those together, I get that? No, this is a factor tree, guys. Factors are things that are being what? Multiplied. So it's no adding or subtracting on this thing. It's got to be multiplication. So what does this thing factor into first? Okay, but where do we start? Where should we start looking to factor something? GCF. What's the GCF? 4 times minus 4, right? Isn't that how you would typically factor this first? Look for the GCF. Okay, so it's 4 times x squared minus 4. What does 4 break into? 2 and 2. Can I factor this more? Yeah, into what? So does everybody see that that's what this thing breaks down into? 4 times x squared minus 4. The x squared minus 4 becomes x plus 2x minus 2, but the 4 really breaks into 2 and 2. So these are all the building blocks that make 4x squared minus 16. Is everybody with me on that? Okay. Now, what about this one? What could we take out first? A 6. What would be left over? Does 6 break down? 3 and 2. Does this break down? Into what? Does anything break down further? No. So now what we need to do is we need to make sure that both are happy. So we have to figure out what mom needs to put into the bag. Poor mom. All right, to make you happy, what does mom have to put into the bag? 2 2s, right? Because if she only puts 1 in the bag, you're going to give her a hard time, right? And she's tired of hearing you complain. So she's going to put 2 in the bag. If she's tired of fighting, she's just going to give in. Give you both things that you want. What else do you want? X plus 2, x minus 2, right? she's got to put in everything that you want right from the get-go, right? Then she can look more carefully at this to see what she needs to add to the bag. So now you're happy. Now she looks at your brother or sister's list, okay? Your brother or sister wants a 3. Is there a 3 in there? No. So a 3 needs to go in there. Your brother or sister wants a 2. Is there already a 2 in there that you can share? Yeah, there's 2 of them, but you only need to share 1, so that's fine. We're good. What about an x minus 2? Yeah, it's there, but what about another x minus 2? Do you see we need to put another x minus 2 in there? Because if only 1 is in there, yes, you can share the 1, but your brother or sister wants 2 of them. Your brother or sister wanted 2 bags of chips, 2 different kinds, or 2 different kinds of cereal, whatever it is. Does everybody see how that works? Notice, guys, there are no x's in there, are there, by themselves? You cannot just grab an x out of one of these things. Let me give you another corny analogy. Each of these factors, this is like a Lunchables, right? You guys love Lunchables, right? Everybody loves Lunchables. So, are you allowed to just buy the crackers out of a box of Lunchables? Or the pizza sauce? Yeah. Well, but if you buy separate crackers, that's a different product, right? You're not allowed to just buy the crackers out of the box of Lunchables, right? So you're not allowed to use an x out of an x minus 2 or an x plus 2. It's the whole thing or nothing. She either puts the whole Lunchables into the basket or the bag, or she doesn't put anything in. Everybody got that? So that's very important that you understand that. Okay. We now multiply this stuff together. What's 2 times 2 times 3? 12. Then we have an x plus 2, and then we have an x minus 2, and then we have another x minus 2. This is our LCM. Does everybody see how that works? Yes, ma'am.
Do they have to be broken down in just terms like x plus 2, x minus 2, or could you have done x plus 2 times x minus 2, like x squared minus 4 times x?
You don't want to do that. You want to break them down so that you can see what has to go in. If you have things lumped together, you won't be able to see how many more of something you need, and you're going to end up putting duplicates in, which mathematically is fine, but in terms of you actually doing the problem, it'll make your life miserable. We're trying to make your life easy, not miserable. Yeah. Because you'll end up, instead of dealing with a problem that just has x squareds or x cubes in it, all of a sudden you're going to get x to the 5th power, x to the 6th power, and then you're going to be expected to factor that thing at some point. So you make life so much more difficult if you throw too much stuff into the bag. We want to throw the absolute minimum. Okay? All right, guys, any questions about finding the lowest common or the least common multiple? Okay, let's take a look now at some of the stuff that you're going to be asked to do besides this. So, one of the things you're going to be asked to do here is you're going to be asked to do things that look like this. In order to add those fractions together, we have to have what? Common denominator. Do we already have a common denominator? Yes, this is beautiful. We don't have to do any work. Mom doesn't have to go to the store. She already has everything you both want. So this now becomes a 4x on the bottom of one big fraction. On the top, 7 plus 3 gives you what? Does that simplify? Yeah. Do you guys see that once you get to this point, this now becomes one of those simplifying problems from yesterday and the day before? Right? So we can simplify things as long as we can cancel factors. There's nothing to factor here, but this factor cancels that one and leaves us a 2 and a 5. And so we get 5 over 2x. So that's a nice easy one with matching denominators. Let's take a look at another one. How about this? 2x, no, let's do 7 over 9x squared. So this is going to be more like what you're really going to deal with. They're not going to give you a whole bunch with like denominators. That's what they do in the Algebra 1 book, but not in the Algebra 2 book. And again, this is not new. You guys did this in Algebra 1. We're just seeing it on a slightly higher level, and I do mean slightly. Okay, do we have a common denominator? Do we need one? Yes. So we have to go over to the side, and we have to see what Mom needs to put into the bag. Now, You don't have to break this down on the factor tree necessarily, guys, but it helps when it's all glued together. So this breaks down into 9 times x squared. 9 becomes what? 3, oops, sorry, it's supposed to be a 3. 3 times 3, what does x squared break into? Times x times x. Okay? What could you factor out of here? A 3x, leaving you what? X plus 1. Now you could break this down if you want. This becomes 3 times x plus 1. So here are the things you want. Here are the things your brother or sister wants. So the question is, what does mom have to put in the bag to make both the brats happy? Yeah, brats. You guys send mom to the store every single time you want something. Brats. What's that? Okay, well then you're brats because you send dad to the store every time you want something. The only way you're not a brat is if, you know, this is what mom and dad want and they're sending you to the store, right? All right. All right, guys, enough kidding aside. Let's get through these examples so I can get you started on the homework. What do you need in the bag to be happy? A 3, an x, and an x. Now you're happy. Now to make your brother or sister happy, we need a 3. Is it already there? We need an x. Is it already there? We need an x plus 1. Is it already there? So I can just put a plus 1 in here, right? No. We need the whole Lunchables, right? You guys see why I was talking about that whole Lunchable thing? You'll be surprised at how many people will throw a plus 1 in there. Because there was already an x, and now we're just missing the plus 1. No, we're missing the whole x plus 1. We need the whole box. So 3 times 3 is 9. X times x is x squared times x plus 1. This is our least common multiple, which means this is now our lowest common denominator. Is everybody with me on what I did? Easy enough? Again, corny as can be, guys, but it helps. It works. Okay, so please use it at least until you really get the hang of it, and then if you don't really need to write it out that way anymore, that's fine. But if you're not getting the right answer, guys, do it this way. It will help you. Okay, the question is, what was new going from this denominator to this denominator? The x plus 1. So if I multiply the bottom by x plus 1, I have to multiply the top by x plus 1. So this is 7 times x plus 1. Notice I did not distribute, did I? Do not distribute yet. Just build the thing first. And I'll explain why in a few minutes here. This is going to help you avoid careless mistakes. Now, it's hard to see how this turns into this. So what you want to do, guys, when you factored this thing into this, you want to rewrite this in factored form. And so the first thing that you're always going to want to do, and we'll see it on the examples from now on, we're going to want to start by factoring both denominators. Okay? So, now that we look at this, what am I missing to build the 9? A 3. What am I missing to build the x squared? An x. What am I missing to build the x plus 1? Nothing. So I have to multiply top and bottom by 3x, which gives us what? Now notice, I went ahead and multiplied those together, but was there any distributing going on there? No. It's okay to multiply stuff together if there's no distributing, but if there's distributing, don't distribute yet. Is everybody with me with how I got to where I am? Now, this is the key thing. We're now going to squeeze these into one big fraction. 9x squared times x plus 1. On the top, I have 7 times x plus 1 plus 3x squared. Notice, did I distribute? No, I combined it into one fraction first. This is crucial, guys, and I'll show you on another example why that's so important. It's going to help you avoid the most common mistake. Now you can distribute. So this now becomes 7x plus 7 plus 3x squared over 9x squared times x plus 1. Notice I didn't distribute the bottom, though, did I? You're never going to distribute the bottom. We want the bottom factored because what do I now need to do with the top to see if this simplifies? Factor it, right? Why would you unfactor the bottom and then turn around and have to refactor it again? The top you've got to distribute because we have to put it in a form that we can factor, if it factors. Sometimes it will, sometimes it won't. But you don't know until you try. But the bottom can always stay factored, so we can do some canceling. So this would be 3x times x. That's the only possibility. 7 is 1 and 7, or 7 and 1. Right? They both match. They're both positive, so I don't need to worry about negatives. Does it matter where I put the 7 or the 1? Am I going to get a 7x in the middle? No. So this one does not factor any further. So this is our final answer. But can you guys see that this now becomes one of those simplifying problems from the last section? So you have to try and factor it to cancel. And sometimes it will factor. And if it does factor, then if stuff cancels, you cancel it out. And if it factors or doesn't factor and nothing cancels, you leave it the way it is. Does everyone see how that problem works? Do you again see why factoring is so important to what we're doing? You can't do this stuff if you don't factor correctly. And that's why I told you that everything we do for the rest of the chapter revolves around factoring. All right, questions on that one before I do another example? Okay, so let's do another example. So what I want to do this time is this one, x plus 2 over 2x minus 2. So x plus 2 over 2x minus 2. And I'm going to do this one the way I want you to really do the process. Minus 2x minus 1 over x squared minus 4x plus 3. Don't go to the whole shopping bag thing right away, guys. The first thing that you want to do, I didn't do it on the last problem because we were just building up to it step by step. Right away, factor the denominators. What does this denominator factor into? 2 times x minus 1, right? Minus negative 2x minus 1. Notice I'm not factoring the numerators. I'm only factoring the denominators so we can see what goes into the bag. The numerators have no effect on that. What does the bottom here factor into? X minus 3, x minus 1. Now it's easy to take your two denominators and see what has to go into the bag. So, what has to go into the bag to make you happy? Now you're happy. What has to go into the bag extra to make your brother or sister happy? X minus 3 is all that's missing. So this then is your least common denominator. Everybody with me? So let's change our fractions. So we have a 2 and an x minus 1 and an x minus 3, a 2 and an x minus 1 and an x minus 3. So what's new on the bottom going from the old denominator on the first fraction to the new one? X minus 3. So I have to glue that onto the top. What was already on the top? X plus 2. Am I allowed to just write it like this? No, why not? Exactly, because if I write it like this, only the 2 is attached to the x minus 3. We need the whole thing attached, so what do I have to put in? Parentheses, right? Okay? Here I had a negative 2x minus 1 to begin with. What's new on the bottom? Nope. Just the 2, right? The x minus 3 was already there. The x minus 1 was already there. All that's new is the 2. Notice I'm not distributing yet, am I? So does everybody see where these two fractions came from? Whatever was new on the bottom, I glued onto the top as well. Now I'm going to squeeze it together into one big fraction. Since this is long, I'm going to get a straight line to do that with. So this is x plus 2, x minus 3, minus 2, negative 2x minus 1, over 2, x minus 1, x minus 3. Let me talk to you guys about why I want you to do this before you distribute. What a lot of people will do is they will distribute this first, which gives you what? And then when they put it together, this thing becomes x squared minus x minus 6. And then they do minus negative 4x minus 2. So what does minus negative 4x become? Right? Look reasonable? Except it's 100% wrong. Why? This negative has to distribute all the way through this thing. The whole fraction has this negative attached. Do you see the issue, guys? What's wrong in here? That should be a positive 2. But if you make that a negative 2, your whole answer is going to be wrong. Does that make sense to everybody? By doing it the way I'm doing it here, hang on, I'll get the questions in just a minute. I'll get you first, Sheldon. Just give me a second. By writing it this way first, guys, do you see that now it's easy to see that the negative has to distribute along with the 2? Everybody see that? That's why I want you to combine it and then distribute, to avoid that negative problem. Okay, Sheldon, what was your question? Yeah, it's already online, but it's assignment 23, page 586, 587, 3 through 21 all. For those of you that have to leave for track. No, we're not going to distribute the bottom ever. We want it factored. Our job is to distribute the top so that we can factor the top. So, let's wrap this up, guys, and then I can get you started on the homework, all right? So now I'm going to distribute this. Again, this becomes x squared minus x minus 6 when you FOIL it out. This, when I distribute the negative 2, becomes plus 4x plus 2. Now, do you guys see when I combine this stuff together, I get an x squared plus 3x minus 4 over 2 times x minus 1 times x minus 3. Notice I did not distribute the bottom. The bottom is factored. That's what we'd like the top to be. But we had to unfactor the top to refactor it because it was factored in 2 chunks, but it was still part of a subtraction problem. We need it to be a complete multiplication problem on the top. So we can cancel. Now, what can I do with this thing? Factor the top. Do you guys again see that this has now become one of our simplifying problems from the previous section? The top factors into what? X what? Okay. Over 2 times x minus 1 times x minus 3. What now happens on this one? Again, will it always cancel? No, not necessarily, but you don't know until you try. So the final answer is x plus 4 over 2 times x minus 3. Do I need to distribute the bottom? Nope, absolutely not. Could you if you wanted to? Yeah, you could write it as 2x minus 6 on the bottom, but there's no need to. And I will tell you that a ridiculous number of times I will see people go that extra step and distribute the bottom, and guess what? They mess up on a plus or a minus and they distribute it wrong. And they write 2x plus 6 on the bottom instead of 2x minus 6. So they had the right answer, they decided to go one extra step they didn't have to do, and now they have the wrong answer. So they end up losing some points. So my advice to you, don't distribute it if you don't have to distribute it. And you never have to distribute the bottom on these. We want it factored, we can leave the final answer factored. Hope, question?
Why is just the 2 multiplied instead of the x minus 3?
Why is just the 2 multiplied?
On the right side of the fraction?
This here?
Yeah.
Why is just the 2 multiplied on the top?
Yeah.
Because we already had the x minus 3 was already part of our old denominator, and the x minus 1 was already part of our old denominator. The only thing that's new was the 2. So we multiplied the bottom by 2, so then we have to multiply the top by 2 as well. That's where that 2 came from. Do you see it?
Yeah.
Everybody clear on that? Any questions about the process? No? No questions? So do you guys see how to go about doing these? They're not hard problems. They're more involved in multiplying and dividing, but they're not hard. The key is you've got to get the what to begin with. The correct common denominator, and you want it to be the lowest one. You don't want extra powers of x floating around because this was easy to factor, wasn't it? But what happens, guys, if this was, like x to the 7th minus 5x to the 6th plus 8x to the 5th minus 4x squared plus 2? How are you even going to start factoring that? Well, to start factoring that, you have to use synthetic division. Okay? So there is a way to go about factoring it, but why would you want to create all that additional work for yourself when just by choosing the right stuff to put in the bag, you could factor this problem instead of this one? And I'm not saying this is what it would come out to be, but you get the idea. I'm trying to make it even uglier than it would be, but you guys see the potential problem by putting too much stuff in the bag? We don't want duplicates in the bag if we don't need them. It just causes us problems later on down the road. Okay. Any questions before I give you the assignment? No? Everybody's good? Awesome. Here we go. Get home.